Hi fellas, this is Chemaddicts again to the solution. Welcome back to another video tutorial. Well fellas, now we're gonna solve the last part of question number 21. Thank God. Today we will finish question number 21. Okay, so let's get started. Okay, so at first let us read this question. Okay, so in here the question says benzyl benzoate is present in many asthma drugs. Okay, so this is the compound benzyl benzoate. Outline how a chemist could synthesize a sample of benzyl benzoate in 3 or 4 steps using benzaldehyde as the only organic compound. Include the reagents and conditions for the steps in the synthesis and draw the structure of the intermediates. Okay, and the total mark for this question is 5. Okay, fine. Well fellas, before going to the question, let us at first concentrate on the structure. Isn't this structure a bit familiar with us? Yeah, you got it right. Okay fellas, let us guess what this sorry for getting cold. It's cold actually outside. Okay, if you have noticed this structure, this is what kind of structure? Can you guess? Okay, let me tell you. Okay fellas, in here we can see that in here. Okay, let me switch off the fan. It's getting cold. Okay, fine. So in here we can see that this particular compound, this particular organic compound has carbon oxygen bond. So which compound has this particular functional group? Yeah, you get it right. This is an ester, aromatic, more particularly aromatic ester. Okay, this is more particularly an aromatic ester. Easter Sunday, sorry, aromatic ester. Okay, since this is the functional group of ester. Okay, functional group of ester. Okay, so you can say that benzyl benzoate is actually an aromatic ester. Okay, so this is an aromatic ester. So we have came to know that this is an aromatic ester. Fine. So we need to prepare this type of compound by only using benzaldehyde as the organic compound as mentioned in the question. Okay, so we should use benzaldehyde as the only organic compound to prepare this organic chemical. Okay, so now let us discuss the question first. Okay, so let us once again read the question. Benzyl benzoate is present in asthma drugs. This is the structure of benzyl benzoate. Outline how a chemist could synthesize a sample of benzyl benzoate in 3 or 4 steps using benzaldehyde as the only organic compound. Okay, so in the procedure we should only use benzaldehyde as the only organic compound. Okay, so here it is also mentioned that include include the reagents and conditions for the steps in the synthesis. Draw the structure of the intermediates. Okay, draw the structure of the intermediates that is involved. Okay, so in this question we should include these ingredients. Okay, so we gonna include reagents, conditions, and the structure of the intermediates as well. Okay, fine. So let's get back to the whiteboard and discuss some of the important aspect of this question. Okay, the concept regarding this question. So in order to make an ester, we will need two things. Okay, the first one is organic acid, that is carboxylic acid, organic acid. Okay, organic acid. Then the second thing is alcohol, in order to make an ester. So for making an ester we need two things, organic acid and alcohol. Okay, so here the only organic compound given here is benzaldehyde. So benzaldehyde, okay, the spelling is right. Benzaldehyde is the only thing given. Okay, so we should work this out by using benzaldehyde only. Okay, so since the only organic compound is benzaldehyde, so we should start from that. Okay, so we should start from benzaldehyde. We should start from benzaldehyde. Okay, fine. So now let us discuss about the steps of preparation procedure. Okay, so the first step of this procedure. So in the first step we gonna carry out oxidation of benzaldehyde. Oxidation of benzaldehyde. Okay, so we're gonna carry out oxidation of benzaldehyde. So the reagents that we are required here, the reagents that are required here are, let's write this down over here. Reagent for this reaction is, first reagent would be, you guessed right, this should be dilute sulphuric acid. And the second thing, you are right, potassium dichromate 6. Okay, solution, or in other words we can say that K2Cr2O7. okay, K2Cr2O7. So in order to carry out oxidation of benzaldehyde we will need two reagent. The first reagent is dilute sulphuric acid and the second reagent would be potassium dichromate 6 solution. Okay, so as you can see that this reaction is similar to aldehyde. Okay, the only difference is this aldehyde is aromatic aldehyde and that aldehyde is aliphatic aldehyde. That's the difference. Okay, and the reaction would be same. That's it. So the condition for this reaction would be heat under reflux, just like aldehyde, heat under reflux. Okay, so here we would also observe color change. Okay, in here we gonna observe color change just like the oxidation of aldehyde. Okay, this reaction oxidation of benzaldehyde is same as the reaction of oxidation of aldehyde that we have discussed before. Okay, that we have learned before. Oxidation of aldehyde, aldehyde is same as oxidation of benzaldehyde. Okay, so the color change would be orange, orang to green. I guess you know that orange is due to chromium, what, orange to green, orange to green. So here orange is dichromate. Orange is due to the color of dichromate Cr2O7 minus. Okay, and green is due to the formation of Cr3 plus. That's it. Okay, well, that's the sound of my bed. I'm sitting in the bed recording this. Okay, by the way, so here it is. So color change would be orange to green. So orange is due to dichromate and green is due to chromium. So that's it. So first, the first step would be the oxidation of benzaldehyde. The reagent is dilute sulphuric acid and potassium dichromate 6 solution. Condition would be heat under reflux, color change orange to green. Okay, as simple as that. So now let's talk about the intermediate that would form here. Intermediate. Ooh. We need to draw the intermediate. Okay, let's put some space over here. Yeah, so the intermediate for this reaction would be the intermediate that is formed here would be aromatic carboxylic acid, that is benzoic acid. Okay, carboxylic acid. Okay, so in here we gonna get benzoic acid, that is benzoic acid. So fellas, hold on tight. This video solution would be longer. Okay, so have some patience because we are talking in details about the concept regarding this question. Okay, the concept behind this question. So we're gonna talk in details part by part for this question. Okay, so therefore the video solution would be longer. Okay, so let's proceed without talking. So in here the intermediate that would form is aromatic carboxylic acid, that is benzoic acid, same as before that we have done in oxidation of aldehyde. Okay, so the only difference is here we will get benzoic acid instead of carboxylic acid. Okay, and the structure, I hope that you know the structure. The structure would be this. I know my drawing is bad. Stop complaining, fellas. So this looks like the structure of benzoic acid. Okay, here the carboxylic functional group COOH functional group is directly attached to the benzene ring, so that is why we are calling this benzoic acid. Okay, so in here what is actually happening, let us observe. Okay, so in here benzaldehyde gets oxidized to benzoic acid. Okay, so in here, just as before, benzaldehyde gets oxidized to benzoic acid. That's the thing happening over here. Okay, so that's the whole thing for the first step. That's the first step for this reaction. So in the first step, we're gonna do oxidation of benzaldehyde, reagent, dilute sulphuric acid and potassium dichromate 6 solution, condition heat under reflux, color change orange to green. Intermediate, aromatic carboxylic acid or aromatic carboxylic acid, that is benzoic acid, and the structure for the intermediate would be this. Okay, and here what is happening here is benzaldehyde gets oxidized to benzoic acid. Okay, finally. So fellas, most of you may ask that why this benzoic acid is acting as an intermediate. That's because at the end of the reaction we won't get this as the product, as the final product. Okay, so since benzoic acid is not the final product, so that is why we are calling intermediate. If you have noticed in the mechanism of organic reaction, you would see that intermediate stays for a short amount of time. Okay, it doesn't get involved in the final stage. So that is what intermediate is. So intermediate means that it would form and involved in the reaction, but it won't end up in the final stage. Okay, we won't see it in the final stage. So that is why benzoic acid is an intermediate. Okay, since it does not form in the final stage. Okay, it forms in the processing stage. That's it. Okay, so now let us move on to the second step. Okay, I hope that you have understood. So if not, please let me know in the comment below. Okay, now for the time being, let us proceed to the second step. Okay, let me put some space over here. Space I'm inserting space over here. Okay, don't mind, it may take some time. Okay, so now let's talk about second step for this reaction, second stage. Okay, so the second step would be reduction of benzaldehyde. Okay, so before in the first step we have carry out oxidation of benzaldehyde. Now we're gonna carry out reduction of benzaldehyde. Okay, reduction of benzaldehyde. Okay, reduction of benzaldehyde. Why? Let's see why. So in here, let us first talk about the reagent that we're gonna use here. Reagent. What are the reagent? Lithium aluminium hydride. Yeah, lithium aluminium hydride, LiAlH4. Okay, which is also called lithium aluminium hydride. Okay, so the condition would be dry ether. Okay, ethoxyethane in this case, dry ethoxyethane. Intermediate over here would be aromatic alcohol. Okay, aromatic alcohol, sorry, not alcohol, not just alcohol, it should be aromatic alcohol. It's not an ordinary alcohol. We are not getting ordinary alcohol, we are getting aromatic alcohol, since the aldehyde is aromatic over here. Okay, benzaldehyde, aromatic alcohol. Okay, fine. So here we're gonna get aromatic alcohol. So the aromatic alcohol, the structure for the aromatic so let us also draw the structure for the aromatic alcohol. The structure for the aromatic alcohol would be like this. Okay, so this is the structure. This would be the structure for aromatic alcohol, CH2OH. Okay, so in here what is actually happening here, just like the reduction of aldehyde, aliphatic aldehyde, this reaction is similar to the reduction of aldehyde. Okay, ordinary aldehyde. So here, in here, benzaldehyde gets reduced to phenyl methanol. Okay, so benzaldehyde gets reduced to phenyl methanol. All right, so here in the second step we have carried out reduction of benzaldehyde. So the reagent that is required for this reaction is lithium aluminum hydride, conditioned dry ether, intermediate, aromatic alcohol. Okay, in this case phenyl methanol. All right, phenyl methanol. So as you can see here, we have carried out reduction, we have carried out oxidation of benzaldehyde, and later we have carried out oxidation of as you can see here, we have carried out oxidation of benzaldehyde and reduction of benzaldehyde. So oxidation and reduction of same compound over here. So since they have provided us only organic compound, that is benzaldehyde as the only organic compound, so we are carrying out oxidation of benzaldehyde first and reduction, and later reduction of benzaldehyde. That's the thing. Okay, so in the second step, reduction of benzaldehyde is carried out. The reagent is lithium aluminum hydride, conditioned dry ether or ethoxy ethane. Intermediate that is involved over here, the intermediate that is formed here is aromatic alcohol. Okay, so now we have got, now let's watch what we have got. Now let us watch what we have got. So the only compound that we have that have provided over here, that we have provided here, is benzaldehyde. Okay, the benzaldehyde is the only organic compound that we have over here. Okay, okay, so in here first we have carried out oxidation of benzaldehyde, and later we have carried out reduction of benzaldehyde. Okay, so oxidation of benzaldehyde is carried out over here in the first step. and on the second step, reduction of benzaldehyde is also carried out. Okay, so oxidation of benzaldehyde would give us benzoic acid. Okay, and the reduction would give us phenyl methanol. Okay, so this is phenyl methanol. Okay, so in the first step we have formed in the first step we have carried in the first step we have formed benzoic acid, and on the second step we have formed phenyl methanol. Okay, this is benzoic acid and this is phenyl methanol. Okay, so in here a benzaldehyde in the first step is oxidized to benzoic acid, and in the second step benzaldehyde is reduced to phenyl methanol. Okay, so now we have now we're gonna have an acid and an alcohol. Okay, acid, organic acid and an alcohol. Okay, so now we can carry out esterification. Since we have got an alcohol, since we have got an alcohol and an acid. Okay, so here we go to the third step. Okay, in the third step, this is the third step, we're gonna carry out esterification. So reacting acid with alcohol, that is esterification, we're gonna produce ester, and that's the main thing for this reaction, the main objective of this reaction, to produce ester. So we can produce ester by the process called esterification. Okay, so there are two possible ways of esterification. There are two possible ways for esterification. Okay, so the one, let's talk part by part. Okay, so there are two possible ways of performing esterification. So the first step, let's talk about the first, reacting aromatic carboxylic acid with aromatic alcohol. Okay, so reacting basically reacting acid with alcohol, organic acid with alcohol, with aromatic alcohol. Okay, aromatic alcohol. So the reagent that would require over here, once again let's talk. The first reagent would be benzoic acid. Yeah, you guessed it right, benzoic acid. And the second would be, yeah, you are correct, 100% correct, that would be phenyl methanol. Okay, methyl, not methyl, methanol. All right, methanol, phenyl methanol. Okay, so we are reacting phenyl methanol with benzoic acid. Okay, so here we gonna have a condition. Once again we gonna have a concentration. Once again we gonna have a condition. Just like a normal esterification, we gonna have a condition, that is concentrated sulfuric acid with as a catalyst and heat. Okay, concentrated sulfuric acid as catalyst and heat, that's the condition. Okay, so here first part, the first possible the first reaction. Okay, the first reaction is reacting aromatic acid with aromatic alcohol. So the reagent that is required over here is benzoic acid that we have formed over here, benzoic acid from in the first step, benzoic acid that is formed from the first step, and the phenyl methanol that is formed from the second step. Okay, so here we are not giving any organic reagent. Okay, these are formed from the synthesis, these are formed from the reaction before. Okay, in the previous step stages. So these are the two organic product that are formed from the previous stages. We are not giving this externally. Okay, so these are formed this should be this, not there. Okay, these are formed previously. Okay, so these are formed previously, so we are just using the reagents that are formed previously, no new reagents over here. Okay, so that's the thing. So the condition here is concentrated sulfuric acid as a catalyst and heat. Okay, so now let's talk about the observation that would form here, that we can get here. So the observation is the first observation would be oily layer of liquid. Okay, oily layer of liquid would form. Then the second observation would be oily liquid has fruity smell. Okay, this oily liquid would have fruity smell. Then the third observation would be effervescence of carbon dioxide is observed. Okay, effervescence of carbon dioxide. Okay, so in here the third step we have carried out. So let us once again review. In the third step we have carried out esterification. There are two possibles of way for esterification. So in here we have discussed only the first possible way. Okay, so since this video would be longer, so we're gonna talk about the second way on the next video. Okay, so in here the first possible way, that is here, is reacting aromatic acid with aromatic alcohol. So the reagent that we would use here is benzoic acid and phenyl methanol. These are formed previously. Okay, condition concentrated sulfuric acid as a catalyst and heat. And observation is observation would be oily layer of liquid. Oily liquid would have fruity smell, effervescence of carbon dioxide. Okay, so that these are the things that we gonna write. Okay, So now let's talk about marks. Since we have got since these are in 3 steps, okay, so the total mark for this question is what, 5, right? So in here let us break this marks down into smaller steps, okay. Let's distribute the marks. Let us see the mark distribution for this individual step, okay. So for first step we gonna gain 1 mark for mentioning what, okay, 5 marks, right? So 2 2 4 3, okay, I have got the mark scheme. Let us see the mark scheme. Let me see the mark scheme, how they have, okay, how they have marked, okay. So here according to the mark scheme, so for mentioning this oxidation of benzaldehyde and the reagent condition, so this whole thing would get 1 mark, okay. And for only mentioning this intermediate, we gonna get another mark, so 1 mark for intermediate, okay. So 1 mark for oxidation of benzaldehyde including reagent condition color change, okay, and 1 mark for intermediate for mentioning the intermediate. And in here in the second step what, 1 mark for mentioning the reduction of benzaldehyde, that is reagent, 1 mark for reagent condition, okay, and 1 mark for the intermediate, okay. So we should include the structure for gaining this 1 mark, okay. So we have gained 4 marks, 4 marks so far. So another 1 mark is for this thing, okay, esterification. So 1 mark, we don't need to write all these things, we just need to write the reagent condition, that's it. Observation is not required, but still we have just discussed. So 1 mark is up to this, okay, condition. So for mentioning reagent and condition, we gonna gain 1 mark and just writing esterification, that's it. Under esterification, if we write if we only write the reagent and condition, we gonna get this, we gonna gain this full mark, okay. So that is how we gonna answer, okay. So fellas, that's it for today. I don't wanna make this video any further longer. I don't know,